This is Engineering 120, Lab 8, Section MO1 for Lab 8. And this is my circuit so far. I did the last circuit, so I'm just going to explain the first two because it's the same circuit integrated. It just adds different more resistors. So for my voltage source, I had 10.5 volts, and my external voltage source I have 4.5 volts, and I have the 200, 330, and 510 resistors, and R1 is going to be the lowest, the 197.4, and that's what they actually measure out to. They're a little less, but it has some percent error in there, but that's all right. So let me measure my voltage source. Let me bump it up just a little bit. It changes because you put it back in the bag. It's real sensitive. Really? This thing's so sensitive. You barely twist it and it goes. There you go, 10 volts. That's what I had on my paper. And that's my voltage source. And now I'll measure my external voltage source. And this is using your potentiometer. So you're gonna have a really high voltage, but once you turn your resistance up on that potentiometer, your voltage goes down to 4.55 volts. And that's what I have for my external voltage source. And so for the first circuit, it just travels through these three resistors. Resistor 1, resistor 2, resistor 3. Ignore that one and that one. And I get IA to be 5.8 milliamps and voltage 2 to be 1.89 volts. And when I actually measured it, I got it was right on the money. So there was less percent error on that first circuit. And for the second circuit, we add this resistor number 4, which was 985 ohms. And you do the same thing. Nothing else changes except you add the new resistor. We do mesh currents for IA and IB, and I solve for IA, IB, and then we can write our equation. I2 is equal to IB because it's in that mesh. And then V2, you just do your ohms times that, or you can measure directly with your multimeter. And I get the measurements I get for I2 are 4.118 milliamps for my mesh analysis and 1.377, but my actual value measured, okay, this is what I actually measured. That's what I got from the equations. So it's a little off, but not by much. It's about 2.8% error. And then for my voltage, I got 1.377. And then now for the last circuit, I can actually measure because that's what I have built right here. Voltage source don't change. IO does not change. V0 does not change. We only add this extra resistor R5, which is 197.3 ohms, which is right here, and we do the mesh analysis. I get IA to be that, IB, IC, and to find I2, it's IB minus IC, which is 6.83 milliamps minus 2, and I get it to be 4.76 milliamps. And voltage 2, I got to be 1.5 volts, and that is from the calculations. Now I can measure it directly for I2 and voltage 2. I'll measure the voltage first. As you can see, I got 1.44. I get the same value for my voltage. So it's a little off from the calculated voltage, which is 1.55. And then for resistance, or for I2, I have to break the circuit, and at right between R1, or you could do between R2 right here, because R2 and R3 share the same voltage. Get my screwdriver. If I can find, there it is. Sorry, I'm trying to measure my current. It's being a little pain in the butt right now. Excuse me. I'll just measure it coming straight out of R2. That's where I did it before, and I got the correct measurement. So yeah, right here I got 4.338 milliamps. I got the same reading voltage, and it's a little less than what we calculated I2B to be. There's a big percent error there. There's something in the circuit or even the potentiometer. But that concludes my circuit for Lab 8, and this is Matthew Goodenough. Thanks for listening, and that is my Engineering 120 Lab 8 section MO1. Thank you. Bye.